Okay, so, I don't know, Anwar, can you get the lights, please? Thank you. So, yeah, that's cool. Let's say, for example, let's go back to the basic example, f of x equals 2x squared. And we ask for the derivative of x squared. Well, if we didn't know these rules, it would take us quite a while to calculate it. Let's just say we go back to the original definition, which was this: f prime x would equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Well, this would be the limit as h goes to 0 of f of x plus h. If f of x is equal to x squared, what is f of x plus h? F of x plus h would be x plus h squared. And when you expand that out, what would that give us?
X squared
Plus h squared. So I would put x squared plus 2xh plus h squared. Thank you. Minus f of x. What is f of x? X squared, all divided by h. Okay. Now we cancel the x squares, and we're left with the limit as h goes to 0 of 2xh plus h squared divided by h. What would come next? You cancel 1h, right? And you're left with the limit as h goes to 0 of 2x plus h, like that. Well, h is going to where? 0. So what are we left with? We're left with 2x. Now, according to this rule here, the constant multiple rule in your worksheet, it's right here, the constant multiple rule. It says that the derivative of anything, x to the n power, the derivative of that, it's saying you bring the exponent to the front, you leave the x alone, and then you subtract 1 from the power. That's all it's telling you. Okay, so if you have x squared, and you're taking the derivative of x squared, we bring the 2 to the front, right? So that would give us 2. Leave the x alone, and then subtract 1 from the power. What's 2 minus 1? 1. There you go, 2x. Look. All of this work was saved using this little formula.
So why don't we have like x squared plus 5? 5 is including 0.
Exactly, because the 5 is the constant rule. Very good. Very good. So what Ian just said was, what if you have a situation like this? X squared plus 5. Then the derivative would be 2x, and then the 5 goes to what? 0. You just go to all subsequent terms. For the example like this, y equals to x to the third plus, let's say, x squared plus x plus 1, let's say something like this. When you take the derivative, this would be what? 3x squared plus 2x plus, what's the derivative of x by itself? 1. Very good. What's the derivative of 1? I'm still going to put the 0 just so we understand what's happening to the term. Very good.
What would it's like divided, like x squared divided by 5?
X squared divided by
5.
5? Okay. So, for example, y equals to 1/5 of x squared. Okay. So the derivative of something like that, bring the 2 down. So this would be 2/5 of x. Now, if you have an x in the denominator, that's a different story. We're going to have to use perhaps the quotient rule, and we're going to get into that as we go along. Now, this is a lesson where we take into account many facets of the derivative, but in its basic form. If you look at the next rule there, it says the chain rule extension. If you notice what the chain rule extension is saying, the chain rule extension is saying f of x, and then it's saying there raised, if you're raising this to some power of n, okay? And then you take the derivative of that. So, this is what you would do. You would take the n, multiply it, leave this alone, leave the f of x alone, subtract 1 from the power, and then multiply times the derivative of the original function, f of x. What this means is the following. Y equals, let's say, x cubed plus 3x squared plus 7x plus 99 raised to the 999th power, let's say. Look at that. I do not expect you to sit there and FOIL that 999 times. That's what this chain rule extension is for. The one that's given on your notes. According to the chain rule extension, you bring the 999 down, and then you leave the inside alone. Then you subtract 1 from 999, which is what? 998. Then we multiply. What do we multiply by according to the rule? The derivative of the inside, right? What's the derivative of the inside? Plus 2 times 3, that would give us what? 6x plus what? 7. I'm going to put plus the derivative of 99 is just what? 0. I'm just going to leave it like that for right now. Does that make sense? Like this. This is good enough.
So in theory, would you still have to, I guess, boil that?
No, of course not.
No, but like, say, like that was 5, would you still have to compute that?
What was that?
So like, instead of like 999, let's say it was like 3?
In principle, you leave it there.
Okay.
But should you take it on an exam, and if it's a manageable number and you see that in the multiple choices it doesn't match what you have, you're probably going to have to FOIL. In an exam, you'd never see somebody FOIL 998 times. But you probably would see somebody distribute this part, like 999 times 3, 999 times 6. You see that? That part can be multiplied, but right here, that's not possible. Well, it is possible, but we just... Good. look at our example sheet in our notes. Go ahead and try example 1 and example 2, please. From your notes, example 1 and example 2.
Like if this was like 5, would you multiply this into this one?
You can't,
and this one?
because it has the power.
Okay,
So this one gets multiplied into this.
okay.
Okay, so this one would be f prime x. This would be 3 times 2x squared to the second power, right? Times what? The derivative of the inside. What's the derivative of the inside? 4x. Which this, now if you look at this example, can you simplify everything? Sure. This would be 3 times 4x, that would be 12x, times 2x squared, that would be 4x to the 4th, and then that would give us totally, at the end, 48x to the what? 5th. Look, if you look at that, and at the beginning, could you have foiled this at the beginning? Yes, you could have. That would have been f of x equals to what? From the beginning, that would have been 8x to the 6th power, right? 8x to the 6th, do you all agree? From the beginning. See, this one could have been done like that, using algebra at the beginning. Now, you take the derivative, and look what happens. 6 times 8, that would be 48x to the 5th. Look, it's the same thing. Yeah, how fun, right, Mr. Karam? Just awesome. Right, but, well, the problem is that, or not the problem, but the advantage here is that this was very easy and it was manageable. Now, does it work like that all the time? The answer is no.
Why did we use chain rule and not the power rule?
It's the same. Well, here we use both on this part.
Then we...
Here I just use the power rule. I use some algebra and then I use the power rule. But chain means when you're doing multiple parts, right?
And so we know when to...
For example, look at this. This is a perfect example of the chain rule. But you're also using the power rule in the chain rule. Because you would you bring the 8 down, right? This would be 8 times, you leave x to the 5th plus 3x alone. And then what does this 8 become up here? 7. And then what do we multiply this by? The derivative of the inside. What's the derivative of the inside?
5x
To the 4th plus 3. So this gives us, watch, look what I'm going to do here, pay very close attention. I cannot multiply the 8 in here. Why is that? Well, this is being multiplied, this is being raised to the 7th power. So I could multiply the 8 over here. 8 times 5, that gives me 40x to the 4th. And 8 times 3, that's 24. And then that, you can multiply it times x to the 5th plus 3x to the 7th. That's a feasible way to present your answer.
So you multiply it by the derivative.
Right. Exactly. Look at number 3. Could I do that just in the normal way? Or what rule would I use here? What rule would I use?
Did you more than one? The power rule?
Look, if you look at f of x, what is 6 to the 3x plus 2? Is that a polynomial? No. What type of rule would I be using?
Constant?
That's not a constant rule either? Wouldn't that be an exponential rule? Doesn't this look like a to the f of x? Watch. A to the f of x power, would you agree? And what's the derivative of a to the f of x according to that exponential rule? It says the derivative would be a to the f of x times what? F prime of x times the ln of a, according to that formula. Do y'all see that on your notes? So this is 6 to the 3x plus 2 times f prime of x. What's f prime of 3x plus 2? What's the derivative of 3x plus 2? Three times the ln of what? 6. That's all. Example number 3 looks like that.
So that is the answer.
That's the answer.
So when it says the derivative of f of x, it's referring to the 3x plus 2 and not 6?
Yeah, well, the f of x that I'm talking about is over here on the formula. It's not literally this one. So it's like if I tell you y equals to 7 to the x squared plus 5x power, let's say. If I look at this, this looks like the format of a to the f of x power. You see that? Go to your chart for your exponential rules. Which derivative would this be? This would be a to the f of x, right? Times f prime of x times the ln of a. Do you agree? So, since this is what I'm treating as my f of x up here, this would be 7 to the x squared plus 5x times the derivative of that, which is what? 2x plus 5, right? Times the ln of what? The ln of 7. Does that make sense? Can you please try example number 4 according to your chart? What minute does it say there on the video? 15 or 19? Oops.